So here I am, and my goal is to basically isolate one of those objects so I can work better, right? I don't need to have everything in front of me and confuse myself. So I will select all of the objects in my scene, and then I will deselect the ones I don't want to. Please, with the fonts. Is this yours? Oh, is this mine? This is mine, sorry. Sorry about that. So I have selected everything, and now I have to just hide. So I will deselect the one I don't want to. Holding control, you can deselect out of many objects and just hide. So you can either type hide, or you can go to this visual here and click once. Your scene now looks empty. It's not really. The objects are here, but they are hidden, no? So everybody, please do that. You have to experiment, otherwise you won't be able to achieve. And let's all make sure that we have such a clean scene like mine. Just one object here, the object you like the most.
Once you hide them,
Yeah.
how can you bring them back?
Right, so you just type show, and everything is back. Or again, through the visual, just click and hold tight and go under the show objects menu.
Where's that?
Control, right? You press shift in order to select more and control to deselect.
Again, what was the button to deselect?
Oh, come on, you guys, please. You have to know these things, right? You have done all of these gorgeous Make 2D drawings. You cannot tell me now how do I deselect an object. So control in order to deselect and shift in order to select multiple objects. So right now I'm holding control and I'm clicking, and this is deselected. If I want to select this object again, hold shift and click. This means you can select multiple objects at the same time. Okay, so I just hided everything and I'm working with this study. Our goal is to create a wall thickness here. Previous class we gave a very simple command that was called offset surface as a solid, and this command generated for us something interesting. I will take this file and I will rename it. So file, save as. And I want you guys to do the same home. If you read the instructions, very first thing I say, for the following parts, save as your original file. So please create a series of different files. Do not mess up your original one. Okay? So save as. Save as number 1, save as number 2, save as number 3. Depending on the different things you are asked to do. Nice. Last. Okay. So here I have this object, and I will very fast perform the offset surface the way we did in class, so you can all remember what happened. So first trial. This object is all one body, so it's connected. All of the surfaces are joined. That's the first case study, and the second case study will be all of the surfaces are alone, they are exploded. So if I explode, now I can touch each of them individually. On the other hand, here I have everything together. So the difference is join and explode. Nice. Okay, so first step, command offset surface. We will do it first to the one that is exploded and then to the one that is joined. So let's all select the exploded and type offset surface. The distance we have been working, I think it was, we said you can choose whatever you want according to your needs. I propose that you work with small thicknesses right now. Otherwise, it's like you proposing a concept of inhabiting the wall and these kind of things if you have a very thick wall. So go small, right? I will say 0.5 and see if this works nicely. Before I hit enter, as you did home, you have to make sure that solid is yes. because you want this to be an actual closed thickness. So solid yes, and corner sharp, otherwise your corner will be round and filleted. Enter. If I zoom in, do you guys, the blue probably is not great for you. Let me place red maybe. Better? A little bit. If you guys see, we have a very good result when it comes to individual surfaces, but there is a problem in the connection of those surfaces. So of course, the fact that this edge is missing is not great. One thing for us to fix that in the level we have, right, with the tools we know, is to just scale as one dimension, one by one, the surfaces. So scale 1D, as you have seen, I can select any of those shapes and say scale in one direction, so scale 1D, select an origin point, then give a point of reference, and then go to the point you want to reach. So always using my snaps, I can go ahead and make this slab much bigger. And enter, I will repeat the command from one ending point to the existing one, and then go all the way and snap to your goal. I will repeat that. As you can see now already, I have something that looks better, healthier. So let's go down here that we have the exact same problem and do the same thing. Would you guys do the same thing, or you have something faster now? Any ideas? Same thing? Right, you could copy that. The problem is, and then you had to only scale 1D in one direction instead of two. It would be even better if this was the same as the one underneath. So then you wouldn't do the same, you would just copy. So I will scale 1D just for us to repeat the steps, and please follow now. Try to do it in your screen so you understand how the command works. So let's all type scale 1D. This is the command. Okay. Enter. Select objects that you want to scale. Let's say that I want to scale this object. Enter. And now start giving origin point and reference point. Origin point, one of the two edges. So I want from this edge to the existing length to move and make it bigger all the way till it reaches this ending point. Is that correct? Yes or no? You guys follow? Yeah? It seems to me that I also scaled in this direction. That was not what I wanted to do. Scale 1D means make only this direction bigger, not also the height. So let's go back. These are very basic things, right? How do you scale an object? And let's type again scale in one dimension. Origin point, this is my origin point. Reference point, the ending, the existing endpoint. And now I'm doing it correctly, right? Now I can snap to this edge, and I know that those two are perfectly aligned. Before I did something incorrectly. I don't know what I did, but I was able to recognize it. This is what I say this is what I mean when I say problem solving. So what you do, you have to observe and understand if it's wrong or right. If it's wrong, you either fix it or you repeat the command if you don't know what was the problem. And I will repeat, and please follow. If you don't follow, you won't be able to do it home. So scale 1D or enter to repeat the command. Select objects, this is my object, enter. Origin point. This point has this specific length right now, the surface, and I want to go all the way to the edge. So I will snap to this ending point. And I'm happy now that this whole shape is closed. I don't have anymore this problem of missing edges. So what do you guys think of this process? It's annoying. It's a little bit hideous because we have to do that many, many times. Marvin, did you have another idea?
Yeah, I was gonna ask why didn't you offset surface, but flip the direction with the results?
So Marvin proposes something that will give me the same problem probably. So he said, okay, you have that, it was exploded, and then you said offset surface, and instead of offsetting towards the outside, offset towards the inside, no? Nice. So I will flip all here in the parentheses. I will keep sharp and solid and distance 0.5, and I will hit enter. And this looks good, but it's not, because those two now have the opposite problem. They overlap. If you try to render that, then you will have two different texture mappings, one on top of the other. So can you guys see that this is what I get? Under the rendered mode, I shouldn't get the same. So you have the same problem. Right, in render mode, if I go here to this shape and copy and offset surface, hard to see. As you guys can see in the edges, I don't have any more this seam happening, right? So both of the offset surface, let's go back to my shaded. Both of the directions will give you some problems. This doesn't look good. The opposite side looks good, but it's not good. So yeah, so that's a problem too. It seems to me that here you would have to go ahead and scale 1D again, or do some Boolean operations. Now, I agree a little bit with Tatiana, that's the long way. In any case, though, it's a way. Let's all have that way in mind. Let's see a few ways that they work a bit faster for us. Now, so this is scenario number one. You just explode, and I will write that down in a dot. Explode, and then you offset surface. Okay, so this is what this was, and I will copy to both of those examples. I first exploded, and then I offset surfaces in either of the two directions, and I got this problem of either overlapping or they don't touch with each other. Now, that was scenario number one. Scenario number two, I get my polished surface. I will copy here. And what I will do is that I will offset, but instead of offsetting a NURBS system, I will offset mesh. Who remembers the difference between meshes versus NURBS? This is going to be a quiz in the end too. It was part of your quiz. No? What is the difference between meshes and NURBS system in Rhino? So, that's a hard question, but everybody please focus. Now we are dealing with very, very sophisticated things in design. So, in Rhino, we have NURBS system and meshes system. If I get a circle, which is a perfect geometrical shape, and extrude the circle all the way, what kind of solid will I get? An extrusion of a circle will give me cylinders. Yeah. So I will get a solid that is perfectly round because it was generated through a pure geometric form, a perfect geometric equation, right? Now, if I say that I have a cylinder, but this cylinder is not an outcome of one simple extrusion, it's basically an outcome of many one next to the other. This is another way of me creating geometry. Now, this geometry is based on polygons. In Rhino, we will use triangles as the basic polygon element. So, the same cylinder, if it's a mess, it means that it can be analyzed into small, tiny triangles. The more triangles I have, the smoother the cylinder. The less triangles, the more edgy the cylinder will look like. So NURBS is basically a perfect geometric shape, a perfect solid, right, generated from scratch from a geometrical form. And a mesh is the exact same shape, right? Both of the shapes exist as both NURBS and meshes, but the meshes are analyzed into many polygons and gones. Specifically in Rhino, the program tries to analyze them in triangles. And the more triangles, the smoother the result. And let's try to visualize that in our screen. I will create a circle and I will extrude, as you all know, extrude curve. I will say solid yes, as you did for your letter, for your Durex letter. And now this NURBS system, if I show isocurves, it has a few parallel lines, right, in height that they are all circles. So all of those lines, they are called isocurves. And here you can turn them off or on. And they show what is the geometry that was used to generate this form. So as you can see, you have isocurves that they are perfect circles. Now, if I say, take this same geometry and mesh it, make it a mesh, make it polygons, right? All I need to do in Rhino, as we said, Rhino is a program for dummies. I just need to type whatever I want. I will type mesh. And I will have to say to the program, how many polygons do you want? Fewer polygons, as we said, it means that my cylinder will be edgy, but also it's going to be less heavy as a geometry. More polygons, my cylinder will be smoother, but heavier as a geometry. So let's go to the heavy side. Let's say OK. And I will move one away of the other. And now you guys understand what is the difference. They seem the same. They will even render the same. Same thing, right? There is a big difference though. There are different geometries. So this geometry is analyzed in all of those vertical rectilinear forms, and the top part is being analyzed into triangles. On the other hand, here you get a cylinder that is based on these circles. So this is NURBS system, this is meshes system. Yes, Elsie. Louder, please. I cannot. I will repeat. Yeah. So I had a line, a perfect line, any geometrical shape, and through extrusion, you get a pure form, basically, a pure geometrical form. So I extruded till I get this cylinder. If I go to the properties of the cylinder, I can see it's a type called closed extrusion. And if I show the surface isocurve, I can see also the lines that were used to generate this cylinder. They are basically circles, no? Now, if I get the exact same geometry and say, analyze this geometry, break it apart in pieces, in polygons, it means that I want to mesh the geometry. I want to create meshes out of it. So this is just terminology for you to familiarize. Right, so we'll type mesh in order to create a new form that is based on polygons rather than NURBS system. NURBS stands for non-uniform NURBS, non-uniform radius subdivisions, right? It doesn't mean anything to you now, I understand. After Visual Studies 2 is going to mean something more in detail. So I will mesh that, And instead of more polygons here, I will say analyze the cylinder into fewer polygons so we can see the difference. Okay? And I will move one away of the other, and this is what I get. The program tried this time, instead of adding all of these polygons in order to simulate the smoothness of the cylinder, the program just created the fewer it could, and now the cylinder is edgy. It's not anymore a cylinder.
Wait, because the cylinder have no polygon shape, that's why it's so hard to.
Right, but any shape out there in the world, right, can be analyzed into small triangles. Any different shape. If I take you, your body, and I start breaking you apart into triangles or polygons, I will be able to create a creature that is as smooth as you look like, right? Now, if I say that you're going to be three triangles, what you did in your pattern abstraction, you said I'm going to abstract that, then you will be head, 2 triangles for the body, and 2 more triangles looking towards, like your feet. It's not going to be you. The more I say make millions and millions of triangles to analyze each of Kelvin's features, the closer I will get to you and the smoother of your curves. No?
For this one, so we're supposed to do our own personal box design?
Right, so here I'm making an introduction to what is NURBS and MESS, just for us to be able to use the meshes as a different geometry in order to offset. Wait till that point, right? So keep that as a general knowledge for now. The understanding of what is NURBS versus meshes, no? Now, Rhino works with both of these geometries, but is better with NURBS. So Boolean operations, for example, that you guys have been doing so far in your cube models can happen very easily with the NURBS, but they can give you many problems when you're working with meshes. So what we do as designers of 3D modeling is that we usually try to get our design as much as possible to the NURBS stage, and then in the end, if there is a step that we cannot perform nicely with the NURBS, that's the time for us to change the NURBS into meshes. Okay? So that's why we have been keeping all of the process steps too. So if something goes wrong, we can go all the way back and redefine our design. So for the last step of our design now, what we can try is instead of using the surfaces, which means NURBS, in order to offset and create wall thickness, let's try to translate that into meshes, and let's see if the meshes work better with the offset command. So that's another tool for you guys to have in hand. You can translate the geometry from one to another every time that you cannot perform an action in Rhino. You will hear in the second year of your studies many other programs like 3D Studio Max or Maya. Yes, it's a mess. You guys, architecture is a very hard thing. So if you guys start working with other programs like these ones, that they're extremely valuable design programs when it comes to more organic forms, free forms, these programs work only with meshes. SketchUp, that maybe some of you are familiar, is working with meshes, not NURBS. So Rhino, that works with both, it's a great program because it can collaborate with all of the rest. So what I recommend is that we design as a NURB system, which means surfaces, and after a certain point, we can then translate our NURBS to meshes in order to finalize the design. What do you guys think about all this? Yeah. Yeah, little by little.
Professor, my first question is how come you have two colors in this? I believe you explained it to us, but I forgot.
How come I have 2 colors?
Yes.
Right, so we did say that. Let's remind. Before I go there though, do you guys understand the 2 different families we have as designers to work with? 2 different geometries? Polygonized, if that exists, and perfect mathematical equation, perfect geometry. These are 2 different things we can take advantage of.
So mass is mesh, and NURBS
NURBS
is offset.
is surfaces, which means perfect geometries, right? And mesh is polygons. So surfaces versus polygons. Polysurfaces versus polygons. That's the difference. And you can easily now be curious through the properties menu. If I select that, this is a closed mesh. If I select that, this is a closed extrusion. You already know that those two are different geometries. Okay, so let's move on. First thing, our goal, the way we did the introduction is because we wanted to use the offset surface command, but instead of offsetting the actual NURB system, we will offset meshes and see if the command works better. Okay? So, let's move on. Tatiana says, how come you have two different colors here and what do they represent? Who remembers? The wireframe. If I go under wireframe, Elsie, I will right click and I will go under wireframe. Here I don't have any color information. I only see the lines, the isocurves. So this is not that. I will go back to my shaded mode. And if I remember correctly, that was again Tatiana's question. So Tatiana, pay attention on the answer now, so you remember. This is a trick I have done in my screen so I can visualize where the direction of the surface looks. So, for example, Marvin said that if you type offset surface, you have all of these arrows. These arrows now look outwards, right? So my surface is directed to look outwards. If I flip those normals and enter, if I flip the normals and enter, the colors are changed. This means that I wore my t-shirt on the other side. So this morning, if I took this t-shirt and put it on the other side and I see the seams, then I would be green. Why? Because my t-shirt is looking, the bad side of the t-shirt is looking outside. How do I know that this is the bad side? Because the good side is the color of my layer. So the red is the color of the spaces layer. So the green is something that I said to the program, visualize it as green, so I know that I wore it in the opposite side. Now, how did I visualize that? Always, whatever is related to the way you work, your workspace will be under options. So here's where you also change your units, no? So you go under options, a new window will pop up. Most of you are familiar with the units menu where you change the units. Now, if you scroll all the way down, you can go under the view menu, display modes. These are the different modes you are working. So Elsie mentioned wireframe before. We have shaded, we have rendered, we have ghosted. Right now I'm under shaded. So we'll click under the shaded and I will realize that I have specific back face settings. So if you guys are doing that same thing together with me, you will see that you don't have back face settings. So you have a single color for all back faces. This is what you should choose. Go ahead in the menu, options, view, shaded, and go under the back face settings. Scroll down and use single color for all back faces. Okay, same back there, can you guys follow? So this now is green, that's why I can see all of those as green. I will make it something different, let's say blue, and now this is changed to blue. Still though, I know that I wear my t-shirt in the opposite side, right? So I will say OK. And I will go ahead and change the direction of this surface. How do I change it? With the direction command, no? You guys remember this visual, analyze direction, or you can just type direction, D-I-R, enter, and here's where you get your normals. You can say flip all of them and enter, and now wear my t-shirt nicely again. And if I offset, now I know that I'm offsetting towards the correct direction. So that was to your question, Tatiana. Is it clear? Okay, I'm repeating very fast. You guys have the video too, right? You will have that recorded already. So, tools, options, this is the window that pops up. You want to go all the way to the view. It's all the way down to the list. You have to select the view you are working on. So now I'm working under the shaded. You may work under the ghosted, right? It's the same menu. So now I will go under ghosted, for example, and I will go under the back face settings, and I will change that to use a single color for all back faces. And this color will be here blue, as we said. Okay? And okay. Now if I go under my ghosted, here I have the same preview. The inside is blue. So I'm gonna move on. We already explored scenario number 1, which is explode offset surface, and then using the command scale 1D, we were able to adjust all of the seams. So scale 1D was the command for us to scale in one direction all of the different polysurfaces. Now I'm going to go ahead and work with the scenario of translating the NURB system, this polysurface, into meshes. So I will just type mesh here. I will select my object, I will type mesh. And my recommendation, when you work with a geometry that is cuboid, it means it doesn't have any smoothness, it doesn't have any curves, use as fewer polygons as possible. Why? Because you don't lose any resolution when it comes to smoothness of a surface. The surface is not smooth anyways. So fewer polygons, okay. Already a new geometry is created. How do I know that? If I go here and select one of them, I have the option to select either the mesh or the polysurface. They are one on top of the other, so it's hard for me to understand that I have two different geometries overlapping. So if I select, I can say select only the mesh and move the mesh right next to my surfaces. And already you can see what we just talked about, right? Here, this polysurface, this NURBS, was generated using a perfect perimeter line, right? A perfect rectangle. Now this geometry here is analyzed into many polygons, triangles, or 4 different angles. So this is a four-gon, this is a triangle. And if I go under the properties, this is an open mesh, and this is an open polysurface. They look the same, but they're not. Now, why did we do that? Because first we wanted to understand now the possibilities that Rhino gives us, and second, because we wanted to test out if the mesh will behave better when it comes to adding wall thickness. So I will repeat the exact same command, which is called offset surface, but this time I will select my mesh. Offset surface. Am I good? What do you guys think? Is it a surface, the one I'm working with? No, it's a mesh. So I need to say offset mesh. No? Offset mesh, and offset surface. These are the same commands for different geometries. Offset will offset just lines. Offset surface will offset only surfaces or polysurfaces. And offset mesh will offset only meshes. So, offset mesh, that's the one I want to work with. And this new window pops up that asks, do you want your mesh to be solid? Yes, we want it to be solid, right? We want it to be a closed thickness. Do you want to offset both sides or one side? It doesn't really matter. You can choose whatever you guys want. And what do you want the offset distance to be? So before we had 0.5, if I remember correctly. And here you can also flip the normals, which means, do you want this to look outwards or inwards? I think they are great the way they are, right? And I will say OK. and this is what I get. And I know it's better. I know that the offset works better here in the triangles. And I'm sure that you guys will be a bit happier with this type of offset instead of the offset surface. It still will have some problems, you will still get some issues, but I want you now to start a new process step, a new grid. So here from Tatiana, I will expect that she creates A, B, C, D, E, F. So she will... Yep. So for the class, what I expect is that you guys create one more grid. I will extend, of course, all of the lines to this. And now I'm creating one more grid with one more extra process steps. This is my F. And in here, instead of offsetting the surface, the way Tatiana has done, and she gets all of these problems, I want you to take this, copy, holding Alt always, make it a mesh. So I will type mesh. You will use fewer polygons, the way I did, okay? Now you have two geometries, one on top of the other. Select the poly surface and delete. And here you have only the mesh. Now offset your mesh. The distance you want, let's say 0.5 again. Solid, you may want both sides or not, and okay. Tatiana, this looks much better, no? So here, I don't want you to fix it yet. Next class we will fix it though. I don't want you to delete it. I want you to create a new grid that instead of offsetting the surface, you will offset the mesh. So what you will be doing is you will copy your very first finalized composition. So you will copy that to the new grid. I'm just repeating right now. Yeah, copy. And then? Very nice, mesh. Fewer polygons, okay. Then delete the poly surface, so you only have the mesh, and offset this time the mesh instead of the surface. Use the exact same distance as you used before, right? Solid, okay, and this is what you will get. Next class we will meet. I was hoping I will do that today, but there's no time and I think it's too much information already for you guys. We will try to fix this object, right? So we will have both a nice NURB system with wall thickness and a nice mesh system with wall thickness. Okay? Questions on the overall? Yes. You just extend. So copy. I just copied this grid all the way, and then I just typed extend. Okay, please, for these questions, spend time alone to figure them out. Now, for this point on, I will consider this type of questions logistics, because I expect many things from you guys. Now we're entering very hard tasks. Okay, so a new step process with mesh and offset of the mesh. And we still have 20 minutes. You guys, we are still in the coffee mood, right? In the energetic mood. So again, please follow. We're not done. We have 20 hard minutes remaining. Yes?
Professor, when we try to do offset surface, it made that way that some parts of my model became mesh automatically. I didn't do mesh.
That cannot be. Let's see together after.
Okay.
Yeah. Next step. 20 more minutes. Please be patient. what we will be doing next is reading, of course. We are still under the number 2 stage of our assignment. And this assignment here, number 2, asks for a series of renderings, but this time, instead of just using one diffuse color, most of you have been using this whitey result, whitey diffuse color, and the white plane. This time we will use an actual material. So for the first time we will say that this composition is made out of concrete, it's made out of wood, it's made out of soil. So we will render, but we will render with materials. And how do we do that? Very easy and very exciting. You guys will work for the rendering of this stage using your mesh. So you will work using the F process step, the one that I just created here. I'm under Tatiana's file and I'm using her composition. It looks nice when it comes to wall thickness. You have just to validate that. And as soon as you are happy with that, you will move on to the V-Ray settings. So the things are the same way you know them. So I have to first pull out my V-Ray menu. So toolbar all the way down. Oops. Keep losing that. And new V-Ray for Rhino. As we did before, first thing you want to go under options, output, and have a very high output. And next thing, material editor. Here's my material editor, and I will create the way you guys know a new material. So right click, create material, standard, and I will rename that to concrete. Okay. And everybody pay attention. So far you have been all changing just the color under the diffuse menu. Next to the color you have this small tiny M that stands for material that now is small. It means it doesn't have any value in there. If I click under the M, a new window will pop up. Here's my window. And this window is waiting for an input, is waiting for a map, is waiting for a concrete texture map. If I go under the known, all I need to do is to say I'm going to import in here a texture bitmap, which means a JPEG or PNG file. This bitmap will be a map of a concrete texture. So you will go under the texture bitmap and your browser will pop up. Now in your browser you should have a series of mappings, a series of materials that you guys like very much and you want to use. I will say in a while very easily how do you find them. Now I will go under some bitmaps that I have in my library and I will share this library with you too. So I'm just searching now my my files. And here you can see what do I mean when I say mappings. So here I have a few concretes, I have a natural wood that I really like, and I will decide if one of my boxes needs to be white concrete, another one black or mold polished, another one maybe wood, another one maybe aluminum. Many different materials you will save from Google and then you will use for your renderings. So let's try with a concrete based material. I will open that. And as you can see, I have my bitmap activated. And now as soon as I choose a bitmap, which means a simple JPEG file, which is here, the file is here. It's called Chafulia, this is my last name, concrete.jpg. I can just say OK here. And now the small m became capital M. It means that I have assigned a specific material. Before I didn't. Very fast, I will go under the render mode and I won't see anything. Why is that? I should have seen here something like concrete, but I cannot. Hmm? I never applied. Right, so let's all be careful. I have the material here. All I need to do is to select my object, right click and say apply material to the selected object. And now I get a preview of how my rendering will look like. I can even render very fast. I haven't saved any nice view now, so I'm just rendering whatever. Just for us to see that for the first time we have a mapping happening. Uh, it's okay. It's not going to take that much. No. If you add reflection, it means that the program struggles more than the actual texture mapping. One by one, one by one. Right. Same thing. If you have a concrete building out there, is this building reflective? Semi. Concrete is basically very rough material, right? Especially if it's not a polished concrete. The building, it has a very sagre type of feel. So it's not like aluminum. If I have a metal building out there, it's certainly reflective, no? So it depends on your needs. You may have materials that they are very reflective, like wood. If it's polished and nice, it means that it will have some reflection. To this specific concrete, I would never add reflection because it's a dirty, unpolished concrete. Now, are we happy with what we see? No, why? Again?
One is not centered.
No, forget about the view. I didn't say view. Bad resolution, I can change my output. Nice. What about the texture? Is the texture nicely applied? No, it's kind of distorted. It's like placed there a little bit randomly, no? So how do I make this map be consistent with the object I have? Now, if I create a sphere very fast and I apply the exact same material, so right click and apply material to selection, this is how it comes. It tries to adjust using the center point, no? But still it's a bit distorted because it doesn't know what is the scale of my sphere. How do we fix this problem? Very fast, it's a very easy menu. Through the properties of my objects. So I will first need to select my object. Here it is. And let's all look very closely at my screen now so we understand the difference. I will get rid of the gumball even because it's a bit annoying here. And I will go under the properties. Here they are, properties. Let's pull them out. This is a closed mesh, nice, we knew that already. Now, next to the object type, you can see you have material and texture mapping. We want to work with texture mapping. So if I go here, I will get information about how this material is mapped on top of this object that is cuboid. Already you can see these visuals and also read. You have all of these options of apply a surface mapping. So if you have a geometry that is more like a surface, this is what you want. If you have a sphere, you want to apply a spherical mapping. Now we have a boxy type of geometry. So first thing I would do is that I would say, okay, let's first apply the box. So I will click here and I will read. What is the first corner of your base? Basically the program asks, I will take this map. Where do you want the map to start from? Do you want this JPEG image to start from this point and then repeat itself and wrap? Do you want the JPEG image to start from the corner? Do you want to start from this surface, from this surface? Give me a reference, the program says. And I propose we as a class, because we are now beginners, we use the bounding box option, which means that the program will create a box that will fit inside here this train's composition and will start from the corner of the box. So bounding box, I will just accept that. So I will just hit enter to accept whatever is in here. Enter. Coordinate system, you work always in the word coordinate C-planes. We have never changed our planes so far. So we never said flip the z-axis, so it's something else, right? So word coordinate system is the one we use, and it has x, y, and z as vertical. And the 0, 0, 0 is your origin point. So enter to accept that too. Do you want your object to be capped? Yes, because I have also surfaces up here and down there. If I say no capping, then it's going to understand only the perimeter of my bounding box. Can you guys see the bounding box?
Yeah.
Right, so this is the famous bounding box that the program is respecting. And the program will start from this corner and will start wrapping this box, no? We want this box to be capped, for sure. So capped, yes. Enter to accept that. Do you guys see how this changed from before? Yes?
Yeah, I can see the difference.
It's truly better, no? Already you can see that the map is not distorted as much. If I select my object and again go under my properties, the texture mapping, for the first time you have this big list. And instead of box, you can change your opinion and say, well, I didn't have a box, or this didn't work nice. I'm going to say box sides only. And this is what I get. Not great. So I will select again, and I will say sphere. Let's apply a spherical. Very bad. No, because I don't have a sphere. I will select and I can play around with all of those, no? Planar. It tries, but because it's UV, it doesn't respect the Z. So those are great, but then the W, which is the Z, it's not respected. Let's try UVW then. Nothing changed. Why? Because this is one object. There are not separate surfaces. The program understands that as one. If I explode, then I will be able to say apply planar UVW.
How do you get the list?
Again?
The list.
The list is automatically there as soon as you apply any box mapping. So I went back to my box, and I can say that I'm happy with that and start rendering using the exact same guidelines. So you need a light, you need a plane, right, to render. Or I can say, well, let's tile a little bit this concrete. So I want you guys to be curious now, and using this window, start understanding how this will work in rotation, repetition, etc. So if I change the repetition from 1 to 100 in all UV and W, which means X, Y, Z, I'm just now saying to the image, repeat yourself many times. This is what I get. Basically, this is my image, this small square. I'm not happy with that because my concrete became a small tile. So I just tiled this bitmap. I can also go here and say rotate that 30 degrees. Let's say UV and W. Or let's leave one of them. You guys, can you see that this now is rotated? Nice. So this is the way for you to offset, repeat, rotate, size, and create different mapping for according to your needs, according to your object. If I go to my sphere and I just now repeat the steps for those that missed me, I will obviously go under the apply spherical mapping, click here and then read carefully. I will accept the defaults, word coordinate, and already my map is better. Already is mapped better following the shape of this shape, of actually the sphere I have in front of me. I will say one last thing on how do you really find all of these maps. It's very fast, it's very easy, and I will close with questions, okay? So keep your questions for just 1 second extra. So where did I find this concrete nice map that I just showed to you? Easily, you go under Google and you type aluminum texture mapping. You go under images, you get a series of different aluminum surfaces that you can use as bitmaps. So all you need to do, and I propose you do the same as you have done for your photo montages, is to go under the search tools and say large size. You want the bitmap to be large. You have less, let's say, options, but at least you know that this bitmap, this image is not going to be pixelated on its own. So go ahead and save the image and use this image as a bitmap for your geometry. Now, for this type of texture, to your question, Kelvin and Donovan, I would add reflectivity, definitely. No? Other ideas I have written down in the assignment. You can type concrete texture mapping, of course, and let's do that. And here you get a series, other ones that they are tiled, ones that they are very dirty, polished, different colors, of course. You can say dirt. Any texture you want. So you have 8 studies, so feel free to have 8 different texture maps over there. So you need to render each of your studies in different material. This is the dirt texture maps. I usually like those, especially for conceptual type of approaches. We're not going to build this cube, so we can just be innovative. We can just have fun. And I believe I have in the assignment, if you scroll down, I have a last semester student that worked with a little bit of a crazy map. And it's colorful and it's happy. Of course, nobody knows what kind of material this is. In any case, though, it's good. I'm sure that she had lots of fun doing it, and she added lots of reflectivity too, and I think it fits nicely. It's nice, yeah. So that's all from my side. I will